everyone, and welcome to section 6.2 on factoring trinomials. I want to first start off with a little bit of review. So we're going to multiply these two binomials together. We can use our old friend FOIL. And then, of course, once we do that, we can clean up and collect like terms. Now, if I wanted to factor, which is doing the opposite operation in some sense, I want to split it into factors. Notice there is no greatest common factor among these three guys, so I can't start with that. What can I do? Well, if I notice what happened over here on the left, I had that 3 plus 6 gave me 9, and also 3 times 6 gives me 18. I want to try to do the same kind of thing here. So my goal is now to go backwards and kind of rewrite this trinomial like I did when I foiled the binomial here over on the left. So the two middle terms added up to 9, and they also multiplied the coefficients to give me 18. If I want to follow that same kind of pattern, then I would want two numbers that would add up to 14, that middle part there, and I want them to multiply to give me 24. In other words, both A and B have to be factors of 24. So what are the factors of 24? I'm going to write them in pairs. We have 1 and 24. We have 2 and 12. We have 3 and 8. And 4 and 6. Now, of these pairs of factors, I also want the additional stipulation that they add up to 14. And the only pair of factors that does that is right here, 2 and 12. So if I rewrite then I would have x squared plus 2x plus 12x plus 24. And now what I'm going to do is follow the exact same pattern. I'm going to go from, say, this step back to the beginning. And if I copy the format, I would have two binomials, each with an x. And these two numbers are the same as these. And there I have my factored trinomial. So this is just one way to factor trinomials. Here I have y squared minus 11y plus 28. So now I want two numbers to multiply to give me 28, but they have to add to equal negative 11. They multiply to give me a positive number, but add to give me a negative one. And so I can infer from this information that A and B are negative. That's because a negative times a negative gives me a positive, like I have here. And a negative plus a negative gives me a negative. So now I'll look at the factors of 28. And I think that's it. So now I need a pair of numbers that adds up to 11. Both of those are going to be negative. 4 and 7 will do the trick. And I want them both to be negative. So I have two minus signs. Okay, another example. I want two numbers that multiply to give me 18, but add to give me negative 9. So let's look at the factors of 18. And the more you do this, the better you will get at doing this step in your head. Since they multiply to give me a positive and add to give me a negative, they are both negative. So I need to add to get 9. 3 and 6 will work. And there we have our factored polynomial. So there is a number of different situations you can kind of run into. Basically, we're starting with polynomials that look like this. So if the signs in the trinomial are both addition, then your answer is going to look like x plus something times x plus something, right? And that something and that other something they're going to multiply to give me c. And add to give me b. We also just looked at this other kind of case here where we have the minus sign on the bx part, but the c is positive. So same deal. We want them to multiply together to give us c, and we want to add them together to get b. The only difference is here now the signs are different. They're negative. And there's two other situations. And in the case that c is negative, since you're having factors multiply to give you a negative number, you can conclude that one is positive and one is negative. The number that is greater in absolute value is going to influence what the sign in the middle here is. So again, I have to have the two numbers multiply to give me c, but the signs are mixed. What separates this third case from the previous two is that while the two numbers have to multiply to give you c, they have to subtract to give you b. And then of the two, the number with the plus sign has to have the greater absolute value to get a plus. Fourth case is pretty similar to the third one, except the situation is reversed. Since I have a minus sign in front of b, I want the one with the minus sign to have the greater absolute value. Really, when you're thinking about the subtracting, you're thinking about the absolute value of that difference should be equal to b. This is very general, okay? So it probably seems like a lot of fried bologna, which is fine if you feel that way, I guess. So let's do some examples. All right, I have r squared minus 8r minus 9. I have two minus signs here. So that means my answer is going to look like, so I'm going to have r minus and r plus. So I need two things that multiply to give me 9, but subtract to give me 8. What are the factors of 9 again? 1 and 9, 3 and 3. Oh, okay, so the one that's going to satisfy that is 1 and 9, because 9 minus 1 is equal to 8. Now, since the middle is negative, the one with the greater absolute value has to go with the negative sign. So 9 goes here, 1 goes there. All right, again, similar kind of situation, except you kind of want to pump the brakes a little bit because this isn't written the same way as the other ones. So let's write it so that the powers are in descending order. All right, now I need two numbers that multiply to give me 48, but subtract to give me 2. let's look at factors of 48. We got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, and I think that's it. Oh, and 8 minus 6 is 2, so that'll work. All right, what if we wanted to factor something like this? So we see that the coefficient on the y squared is not 1 anymore. So we need to adapt a little bit. So we have something of the form ax squared plus bx plus c. The book uses what it calls the AC method, which is kind of a cutesy name for factoring by grouping, basically. So here's how it works. You want to find two numbers, m and n, that multiply to give you a times c, and add up to give you b. Then you're left with something like ax plus mx plus nx plus b. And then from there, you just factor by grouping to get your answer. So let's try that out. Okay. So a and c are there. So I want m times n to be equal to 4 times 3, which is 12. And I want m plus n to be equal to 8. Let's see, for factors of 12, I have 1 and 12, 2 and 6, 3 and 4. 2 and 6 will work. So this is equal to 4y squared plus 2y plus 6y plus 3. And then we see that the first two terms have a 2y in common, and the second pair of terms just has a 3 in common. So altogether, now considering this is one term that we're factoring out, and there we have it. This is a little bit more reliable than guessing and checking. All right, one more example. Promise it's the last one. We have 18w squared minus 39w plus 18. I want to do the same thing here. I want m times n to be equal to 18 times 18, which is equal to 324. And since I have a negative sign in the middle and a positive sign at the end, both of my numbers got to be negative. So I'll have m plus n equals 39. Okay, factors of 324. Oh, here we go. 12 and 27. All right, for this first pair of terms, I have 6w as my GCF. And then over here, I have a negative 9. And there we have it. Next up, we're going to be looking at factoring these so-called special products. So it's going to be special time.